Alright, let's see the ninth day challenge from lead code, which is Backspace String Compare. So the problem is you are given two strings S and T. Return if they are equal when both are typed into empty text editors. The hash means a backspace character. Let's look at one example to understand what the problem is. So here the S is A, B, backspace, which is the hash sign, C. So we are going to have A, C, and then here A, D, hash sign, which means backspace, C. So AC. So the final strings are A, AC, AC. So both are equal. We are going to return the true, right? And if you look at this example, AB double backspace, so it's going to be empty string, and then C backspace, which is empty string, and then D backspace, which is going to be empty string. So we are comparing two empty strings, so these S and T are going to be equal, right? So let's write the code. So what I'm going to do is first I'm going to write the code, then I'll go through the code with a given example, and then we'll talk about the runtime and space complexities, right? So first thing first, I am going to have string clean as. Okay, so I'm going to have a method called clean string. So what it does is going to remove the backspace and then return the final string. Okay, and then I'll be having the same way clean t, and it's going to do the same thing too. And then finally I'm going to be return compare string. It's going to take two input strings. This method is going to take two input strings, and then clean t. Right, so I need to have two methods. First one is the clean string method. Okay, so let me write that one. Boolean clean string, it's going to take a string s. Okay, so I'm going to have a stack of characters, character st new stack, right? And then I'll be going through every character from the given string. I less than s dot length I plus plus, right? And then character c is going to be equal to s dot character at the given position. And then now we got the character from the string, and then I'm going to checking if c equals hash sign. Okay, if the given character is equal to hash sign, what I'm going to do is, that's a backspace, I'm going to remove the first character, right? So instead of remove, so what I'm going to do is here is I have a stack and I'm going to put it in the stack, right? So first thing, I'll be checking whether the given stack is empty. If the stack is not empty and we found a hash sign and the stack is not empty, I'm going to remove the very last element from the stack, stack.pop, right? And the stack is not empty, we found this character hash, right? Otherwise I'm going to be using stack.push the given character. So here what I am doing is I have a stack, right? And I am going through each character from the given string and then getting the first character and check, hey, the given character, are you equal to this hash sign? If you are equal, I supposed to remove the right before the hash, what the character is in the given string, I need to remove that, right? So that's the reason I am going to the stack and pop. But before I pop, I need to make sure stack is not empty, right? If the stack is not empty, I'll be removing the what? Otherwise, I won't be removing it because tag is already empty, so there's no way I can remove it, right? And if there is no hash sign, I'll be pushing the element into that hash. Okay, so now we have a hash, and that hash contains all the characters what we're supposed to have in the final string. Now I'm going to convert the given tag into string. So I'm going to be using a string builder to convert the tag into string. For we do while stack is not empty. Until stack is not empty, I am going to be popping each element and appending that into the string build. Pop, right? So when I'm coming out, that means the stack is empty and the string builder. So it's having all the characters what we need. Okay. And then I'm going to convert the string builder to string, right? So now this method, what it does, it's if it takes a string and it cleans the string. In another word, it removes the characters which it needs to remove. If there's a bag hash sign, it removes the character right before the hash sign. Okay, and now let's go to the final method, which is excuse me, this method needs to return string, and the final method compare string private, this one needs to remove, excuse me, need to return a boolean, right? It's got like string s1 comma string s2, right? And then what I'm doing is, first thing, I'm going to be checking s1 strings length s1 dot ngth length, and the same way I'll be checking s2's length too, right? S2 S1 length and then S2 length, right? And then first, if S1 length is not equal to S2 length, we know that these strings are not equal to S2 length. I can simply say return false, right? And if the lengths are equal, then for int I is equal to 0, I and s1 dot length I plus plus character c is equal to s1 dot char at I if fc is equals to s2 dot char at I. If it's not equal, I'll be returning false. Otherwise, if there's no false in the first line 34 or 39, after I exit from the for loop, I'll be returning true. Okay, so what this method does, this one compares two strings and this one clean the given string, and then finally this one would excuse me, like first this one's going to clean the first string, this one's going to clean the second string, this one's going to compare the strings, and then finally we'll be getting output from this compare string. Let's run the code and see whether it's working. C is equals equals wait, oops, Okay, so this method works fine. I accidentally type is equal instead of equals. So okay, this is the code to solve the given problem, right? And let's quickly analyze the time complexity. Okay, so first let me just write here. Okay, actually before I go to time complexity, I just want to go through one example and see how it works. Okay, so let's get this example st. All right, right. So the first one is a, the first string. I'm going to cut the clean string, clean s. First string is going to be this string, which is abc. So this abc will come to this method abc. So when I come to ab hash c, right, so I'll be having this new stack, and then the new stack I'll be going through each character, and then when I find the hash, and if the stack is not empty, then it's going to pop the element. So initially in the first, I'm going to just put the stack here, stack, and then this is how the stack get pop tag gets stack gets data. First a will get stored, and then b will get stored, and then when it comes to the third character, which is hash sign, you will come here and say, hey stack, are you empty? No, I am not empty. So it's going to pop the very last element, which is b would be gone, and then finally the c would be added. So in the stack we'll be having a comma c. So in the clean s is going to be having ac, and the same way clean t is going to be ad. A and d get stored. So this is the clean s value, right? And then when it go to the clean t, it's going to be the same way. In the stack, first a will get stored, then the stack d will get stored, then as soon as there's the hash d will be removed, then we have c, right? So in the a clean s clean t, we will have those two clean strings, and then finally in the compare string, I am checking the length of the strings, and then finally I am checking whether each characters are equal or not, right? So that's how the code is working. Now let's quickly analyze the time complexity. Time complexity. Time complexity. So okay, so what's happening in this clean string, I'll be going through the all characters. Okay, all characters. If the, let's say if this is n, it has n elements, I'll be going through all characters of length, all characters from s and all characters from t, right, to clean the strings. And then when I'm comparing, I am going through them again too. So I could say simply time complexity is big O of n plus m. Here n is the n here I could just say, just for the sake of clarity, n is the length of string s, and then m is the length of string t, right? So that's the time complexity. And then space complexity, did we use any extra data structure? Okay, did we use any data structure, extra data structure? We are two times we are creating stack, right? So the string for string s we are creating a stack, and then string, and then other string also we are creating stack. So the space complexity also going to be as same as time complexity, big O of n plus m. Okay, and I think that should be it, because I was just thinking of giving you like a in detail space complexity, like but how many variables we have. But for the big O of space complexity, the big O of n plus m is the space complexity for this given problem. So that's how you can solve this problem. Thank you so much.